Okay. Thank you. So we talk about the core concept first for 3 hours. First of all, the DIATwin solution we can use for Presales to proof of the concept. We can have a 3D CAD by ourselves design or provide the customer. Then we implement to the digital twin, and we can simulate like the movement of the robot from which point to which point, and then find out the cycle time to prove our concept is doable and achieve the cycle time. Then after that, we can start prototyping, like implement more component, like multi-robot. Then we can optimize the parameter to find out from the raw material from the first of beginning to until the final product. Then followed by the planning the workflow, like the sequence flow from the pick and place, then the path for the robot movement. And this image example is the dispensing on the like gluing those, and we can commissioning with the digital twin to finalize all the cycle time and tuning to improve the speed. Then the sequence is workable or not. And the end, we can integrate to the real machine design. So we can do this like include the software side for the programming PLC or the PC-based programming before the hardware design come up. So this Presales concept, we can increase the workflow from 1 week to the 1 day to prove the concept. We have plenty of library, include third-party and Delta model robot. Then we just assembly by drag and drop and provide the low coding to complete the sequence below. So this support 3D CAD like the step file from third party, like from the inventor, also can direct drag and drop to inside our 3D work to assembly the machine up. So this is virtual machine prototyping. We can support the C# programming for the PC base and the PLC base. By the example, we're using the Cortices. Cortices support the soft PLC, or we can use the hardware PLC to link with the digital twin to move the actuator, motor, and robot. So this is an example of the C# using the PC base, and the layout is mostly similar like the PCIe card, the Delta motion card. And we can operate by the C# API. Then the server on job, the server movement with the interface. Like select the axis, this able to choose the 3 axis, setting the distance, velocity, then start jogging or moving. Then we can verify from the position at this panel, and some the parameter tuning for this type. So it's a layout to show the sensor, the homing. Yeah, now it's showing the homing mode and set the parameter. Okay. Then press the home, then the robot will move the home sensor exactly same like the physical servo drive. So this overall commission, like the group dispensing, we can predefine the path to find out which is the best way, the most suitable way for the design. Then we can simulate the digital twin will help to generate the path. This path the detail will show on tomorrow for the robot session. That is an example to apply in the digital twin. And this slide will show the cycle time, how much movement for the total. Okay, that is the next. So now we get some briefing on the DIATwin interface. So this software layout, we got few sections. The first section is the menu bar. We can switch the layout modeling, programming those in the menu bar. Then the second one is component tree. Like usually we want the DIATi file will consist multiple components. Then we have to choose the component to define the behavior and the device on the left panel. And the program also will show up on the left panel. The third one is the rendering of the 3D work. Like we can interact like drag and drop, zoom out, zoom in, move the component here. The fourth panel is the console. Normally we use for the troubleshooting, see the message, any like the robot is off of position, error, those in this section. The panel 5 is the properties. Normally we fine tune the position, adding the physical, the bounding box, or choose the controller like internal run with DIATwin or run with external like the C# those. So the next is modeling. This modeling like we can extract component or link file from the 3D step file and assign the behavior like movement like actuator, rotary, lighting, I/O at this side. The third one is the programming, and we can this one is collision. The programming we can do the low code program at this session, some basic if else. Then we can export the robot application to the robot data point table at this side. The fifth one is the collision detection. Like we can enable to find out the robot have any collision with the product or any other component verified here. This one, this analysis is able to monitor the scope we use to monitor the model position, robot position, then I/O and the timing. While the grand chart we can monitor the process like the program we define at the program side, then check out with the cycle time. This example to show the I/O signal and the robot position. And we can do like tuning the homing position, I/O triggering from this session. So this one is the grain chart display. You can separate by the step and the cycle time taken from to help us reduce the cycle time in the process. So these are our basic two extension file we usually use for the digital twin. The first is the DT, is built out of a component like a single robot, the gantry, Then we have the basic properties like the dimension, the coordination. Then behavior is like the conveyor movement, I/O triggering, vacuum crimping. For the DTL is stand for digital twin layout file. It's assembly of multiple DT to complete a project file. Normally we can run with the program at this station, the simulation, then export to the radio. So this built-in library, mostly we can support most of the Delta product, Delta robot, and some basic component like gripper, some testing tools, sensor from this session. Is so this side we can always update to latest of the library from official. Then we can drag and drop the robot to the 3D work by double click or pull to the 3D work. So this this demo for the screwdriver solution. In this example, we have the robot DIATwin at gantry for the screw put in place at screwing process. Then the dual track conveyor to send the material to screwing. Suction trick is the one to pick the cover to the material. So here's a video to show the material sent to conveyor until a sensor stop the conveyor. Robot will pick cover to the material and start screwing process. Okay, it will disappear. And another one, repeat the process. And with the step, the basic assembly process we're using slot. Slot consists of two components, is the parent slot and child slot. Mostly we assign the component to the parent is by moving the child slot to the parent slot. So the both of component is linked into one device. And this time when we do any movement, both of the component will move at the same time. So the green link image icon is show out once we slot into multiple devices into a single component. So this is an example to slot, and we move to here. Here's a layout. Then we can just drag and drop the PT file to the 3D work. Usually it takes some time to importing.
People who cannot use DIATwin right now.
Yeah. Even I already installed the DIATwin. So the license dose is okay already, right? License able to run. Yeah. Okay. So I complete again by using the slot here. Okay, first of robot base to the table, copy the robot. This cover except the PLC. Oh, okay. Then for the conveyor, entry bracket, the screwdriver fitter base, screwdriver fit, screw fitter, entry robot, screwdriver, and the vacuum pad, suction pad. And we can disable the everything, the frame, and this is the final layout. So it's okay?
It's okay, it's okay.
Okay, then we move to next step. So next is on the programming side. Yeah. So the next we can job is the robot. Like move the robot to the pick up the cover from the cassette.
Okay.
For the yeah.
Okay.
This one I show later. I show the slide first. Explain the slide first. So the so for the red section, right, we can choose the component with different program based on the component like the robot, the host PLC, the gantry.
Okay.
Detail will show later. So this one is directed for the demo. So from the program, now is for the robot. You can select job. And here is a job by snapping. And we can move the robot to any location we click. Yeah, we can set the orientation without the orientation also. And play around with this. Yeah.
Robot.
Have the robot DIAV70L from the program editor.
Okay.
Then select the job. Enable job as snap. For the just now, the rotate the robot is because the job by here, so the robot seems direction in this direction. So if something like go out of the position, it will display the error here. And then we can manually pull the thread, the robot arm. If something like collision, they will should display a red color. For the complete can try with change the program to case 2, so can see the collision. Yeah.
Program 2 แล้ว
Yeah, program.
Program 2 แล้ว
The pulse first, initialize. Then for the robot, this one, select this for case 2 and G1. The robot program. Select the core for the case 2 and G. Yeah. Then for the main master control also. So call for the case 2 also. Yeah. My cycle box. Yeah, case 2 for the robot, case 2 with the engine. Yeah. So for next is from virtual to physical deployment. Okay, this one is based like the Chinese. So this one is by import the CAD, then we start for the engineering process from the CAD file, like programming, searching the path for the robot. This after auto generate the path, like we got one feature for the path. Then they can auto move the robot around the path generated. And run, they will auto move. But this one will be shown on tomorrow on the robot session.
Okay, robot section.
Yeah, robot session. Go for next first. Yeah, this example for with another demo, another model or just now with this model. Yeah, we'll show detail on tomorrow. Yeah, this one, if got time later can start simulate, but now I go through first. We can show the video first. Okay. Yeah, this select the curve to the robot for the movement, tools movement. Then we can adjust how the density, the point offset. This one is adjust the density like nearer more point, but the result will become lower. So this is able to cancel reselect the curve easily. Like so with the starting point, the ending point, the one is the start, the starting point, then arrow is the ending point. Okay. And sometimes out of the curve, we can move the linear. Like the one that move until this section is the linear path. Then we choose to move L to pass the curve to another section. This one is the exercise, but I think we can proceed for later. This one is move the path along the fan casing. Now the robot start moving around the fan casing. The tool just now they move the physical part. And the robot also should find the fan casing and move along the curve. This one is the export the just now the path to the data table. Then we can import for the data controller. Yeah, and also the data Lua language. Yeah, this is the result. And another one is the local Lua language. This one is point data. They will import the file inside. And then the raw, then they import the file. Then we can set type without reduce all the data point. And for the next, this one is export to RAW. LA, and export from this session for the data language. Then this is the result. So they already positioned for the every data point. Then the move part.
This result potential.
Yeah, this will can directly download to the robot controller.
You mean you use the program to create and for the measuring
Yeah.
and we get the exact data.
This one is the robot language. Just now for this side is the Excel data. So this already program come with the program. We directly plug into robot controller, they will auto run.
Oh.
Yeah, this is already program part. So no double work.
Right.
But just need to make sure the CAD file is actually same as the physical device. And for next session, we come to the motion part. Wait for one, wait to move. Yeah, for this motion part, we got one API. And this API you can choose by running virtual or running physical. For the physical part is same as the PCIe delta motion. So this is a sample to show simulation with the C#. But require install the Visual Studio first. And file initialize the server, find the axis, and start move with the position. One. We don't have the example here. Maybe later. This also will show on the tomorrow motion part.
Okay.
Yeah. So the first is just simulate with the one axis. Now this is a step. Initialize, find the axis. Here total 9 axis on the just now demo, include gantry. And this for the section 2 is run with multiple axes. So you start with the multiple synchronized, then select 3 axes on here. So the gantry robot will move together. And the next part is just homing only. So in this homing, we can show different mode. Like for the limit switch and move until limit switch and fire for the first T pulse or the homing sensor.
Home sensor.
Yeah. How to arrange? This is same as the real case of the homing position. And this one is home with the limit. And now you home with the home sensor, I think. Yeah.
Lưu đây.
Còn program đây.
Có cái program này. Mình phải trả nó về thì đấy là gì? Cái đầu sang ngày làm gì?
可是是不是走下去教？